Here's how to derive a probability formula. It's always best when we can derive the formulas instead of just memorizing them, because memorized formulas are easily forgotten. And even this formula here is pretty simple. But say years down the road you want to use the formula but you're not sure if it's right or not. You can think to yourself, it's something about multiplying probabilities, but I'm not sure if that's right. And then this way, since you know how to derive it, then if that time ever comes when you're not sure if it's right, then you can rederive it and know that you're right. Okay, so we have three cards, cards A, B, and C. Cards A and B are the winning cards. Card C is the losing card. So as Meatloaf said, 2 out of 3 ain't bad. We have a 2/3 probability of getting a winner, and probability is just winners, number of winning cards over total cards. Okay, so if we want to look at any individual permutation here, for example, the permutation of we're going to do 3 draws with replacement, which means we draw a card and then we put it back in the stack. So we want to get a winner and then a loser and a winner in that order. The probability of a winning card is 2/3, which means the probability of a losing card is 1/3. So winner, loser, winner, you just take 2/3 times 1/3 times 2/3. You just multiply the probability of a winner times the probability of a loser times the probability of a winner. And that comes out to be 4/27. So that's the formula. Stay tuned and don't touch that dial if you want to see more explanations and the proof. I'm going to gradually make this more complicated with each page. So on this page, we want only 2 winners with 3 draws. Notice I said only 2 winners instead of at least 2 winners. So that means, for example, with only 2 winners, we can't have 1 winner, we can't have 3 winners, we can only have 2 winners. Let's look at the permutations right here. We could set them up as binary. Just pretend that your W for the win is a 1, your L for the loser is a 0, and set it up in numerical order, 0, 1, 1, 1, 0, 1, 1, 1, 0, or lose, win, win as for the first permutation, and then win, lose, win for the second, and then win, win, lose for the third. In all scenarios, in all these permutations, we have 2 winners and 1 loser. So it's 2/3 times 2/3 times 1/3 for each individual permutation. Then we multiply that times 3 because we have 3 permutations. So 2/3 times 2/3 times 1/3 equals 4/27 times 3 because we have 3 permutations equals 12/27. On the next page, it'll get a little bit more complicated, and then I'll show the proof. Okay, so right here, notice the problem I just did, I said only 2 winners. Now I'm going to say at least 2 winners. Thus, we can have all winners, winner, winner, winner. So we have 3 winners, plus we have to add, so we have to add that permutation to all the permutations with 2 winners, which is right here. For 2 winners, it was 12/27. So we add that to 3 winners. 3 winner permutation is 2/3 times 2/3 times 2/3, 2/3 quantity cubed, plus 12/27, and that comes out to be 8/27 plus 12/27, so it's 20/27. By the way, I think there's more to this equation, and there's more ways to modify this if you're dealing with something really complicated. Like if you want 23 winners out of 57 draws or something like that. So I was thinking I came across some sort of formula in the past that showed that, but I don't remember it, and I definitely don't know how to drive it, so I won't cover that here. So for this video, I'm just going to stick to the simple stuff, and I'll show the proof on the next page. Okay, so this is really why I'm doing the video, because I hadn't seen this proof before. What we can do is take our 3 cards, and we're going to do 3 draws. So I just divide everything up into thirds, then divide those thirds up into thirds, and divide those thirds up into thirds. So it's like we got a big piece of cake here. We'll cut the cake into thirds, then we cut each third into thirds, and cut each one of those thirds into another third. So here's how you can derive this equation or make sure that it's accurate. For example here, we want the permutation, this specific permutation of winner, loser, winner. If it was something like loser, winner, winner, then that would be the same combination because there's 2 winners and 1 loser, but they would be in a different order. Thus, it would be the same combination, but a different permutation. So a permutation is a combination in a specific order. Okay, so here's how we do this. I'm going to break it down and make it look super simple. It took me a long time to figure out how to make this look easy. We take this permutation, winner, loser, winner. Come over to our chart here. We want a winner for the first draw, and then a loser for the second draw, a winner for the third draw. So for the winner, even though we have two winners, both A and B are winners, let's just look at one winner. So let's look at A for the winner. Now we want a loser, so that means we have to go to C for the second draw. And then we want a winner, so that means that's A and B right here for the third draw. So we look at A and B. This is 2/3 right here. So for the winner, it's 2/3, but it's 2/3 of 1/3, 2/3 of 1/3. So notice what I did here is I took the losing card, or sorry, the winning card, which is 2/3, multiply it by the losing card, winner times loser. But now this loser, it's 1/3 of 1/3. This C right here is 1/3, but notice the C right here is 1/3 of 1/3 because here's A, B, and C. So here's our big piece of the cake. This C is 1/3 of 1/3. But notice now we have to take this and we have to multiply it times 2 because we have two winners here. So it's 1/3 times 2. Thus, for the final form here, we have 2 times 1/3 times 1/3 times 2/3. Bring the 2 over to the top of the numerator. You got your 2/3 times 1/3 times 2/3 equals 4/27. And that's it. That's the proof. I'm going to show some practice problems at the end of this video just because this is actually kind of tough to nail down when you first start doing it. At least it was for me, and I kept messing up and I kept making tons of errors. But after I practiced this several times, I think I got pretty good at it and I stopped making so many errors. And now I'm going to show a different variation of this. So right here I'm going to say we want at least one winner. Instead of at least two winners, we want at least one winner with 3 draws. So if you look at all of our possible permutations and combinations, we have 3 wins as an option. We have 2 wins as an option. That 2 wins was winner, loser, winner, 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 loser, and so on. And then we also have 1 winner as an option for another combination, which goes lose, lose, win, lose, win, lose. Because notice in these different permutations here, in the bottom one, we only have 1 winner. And the next one here, we have 2 winners. So now I'm going to show an easy formula so we don't have to add up all these permutations. And next page. Okay, previous page on the left where I said at least 1 win with 3 draws. New page on the right, at least 1 win and with 3 draws. So if we have at least 1 win, all that means is we did not get 3 losses in a row. So 3 losses in a row would be loss, loss, loss for all 3 of our draws. The probability of a loss is 1/3. So you got 1/3 times 1/3 times 1/3, 1/3 cubed, which is 1/27. I'll show what that looks like here. 1/3 right here of 1/3 of 1/3. So right here, 1, 1, 1. So this is 1 out of 27 options. So it's 1/27th probability of getting 3 losers in a row. Now we can just use some basic logic. Probability of winning plus probability of losing equals 1. In other words, 2/3 plus 1/3 will equal 1. Because we have a 2/3 probability of winning, 2 cards are winners and 1 card is a loser. Add 2/3 plus 1/3, you get 1. So we have 1 minus the probability of losing will give us the probability of winning right here. 1 minus probability of losing equals probability of winning. And next page. Previous page on the left here, 1 minus probability of losing equals probability of winning. New page on the right. So what we have here, it's the probability of losing. Every time it's 1/3 to the 3rd power, because remember it goes 1/3 of 1/3, 1/3 of 1/3 of 1/3. So it just comes out to be 1 minus 1/3, quantity to the 3rd power equals your probability of winning. And this genericizes to 1 minus number of losing cards over total number of cards, quantity to the number of draws or the number of attempts. And that equals your probability of winning. So 1 is the same thing as 27/27. So 27/27 minus 1/27 equals 26/27. Also, if you're just playing around with this probability tree and trying to get an intuition of this and a feel for everything, it's kind of fun to check this. If you only have 2 or 3 cards and 2 or 3 draws. So you can see here if we have 3 cards and 3 draws, if you're going to get a loser, loser, and then a loser, you're only going to get 1 permutation out of 27 total. So 27 minus 1 equals 26. And then right here, I just wrote probability versus odds because I occasionally hear those used interchangeably. Colloquially, they are used interchangeably. But technically, probability is the number of winning cards over your total. And then for odds, there's several different definitions on that, and I couldn't get any consistent answers on Google. And I've occasionally checked this over the years, like every few months I'll check it, and I get different responses. So with odds, one way to represent this possibly is your winner colon losers, or which, for example, that'd be 50-50 odds, half winner, half loser. Or say, for example, you do 5 to 1. You could also represent this as a fraction in addition to a colon. And theoretically, at least according to Google, that means if you bet $1, you'd get your dollar back, plus you'd win $5. And then there's the money line. According to Google and from what I read on the internet, you can check it yourself, but the money line odds, the positive or the plus goes to the underdog, the negative goes to the favored opponent or the favorite opponent. And so if you have a negative 150, for example, on the odds for the favorite opponent, everything's based on 100. So if it's negative 150, that means you need to bet $150 to win 100. So that means you get your $150 bet back plus an additional $100. And then if it's a positive for the underdog, if the underdog has a positive 150, that means if you bet $100, then you will get your $100 back plus an additional $150 if the underdog wins. On the next page, I'm going to show some practice problems. Normally, I never do practice problems on this channel, but in this particular scenario, I found out I had to keep practicing because I kept making little errors and it was kind of hard to keep everything straight in my mind. So I'm going to show 3 practice problems really quick. On these 2 pages, I have the probability tree on the left. I have the permutations on the right. It's best to have a system whenever you're dealing with something sort of complicated like this. So my system is to make a trail going from left to right, and then you backtrack on that trail from right to left, and I'll show what I mean. For this individual permutation, we want win, win, lose. Pick any winner, so I'll just pick A, even though we have 2 winners, both A and B. A is the winner I'll pick, so we want to go from winner to winner. So I'll go from A, and then to loser. So that'll be a C. So it goes A, C. So that's the left to right part. Now I'm going to do the right to left part. So the loser is C right here. C is 1/3 because we have A, B, and C. But this C right here is 1/3 of 1/3, and that's A. So we have 1/3 of 1/3, but notice how we have 2 winners, both A and B. So the winner here is actually 1/3 times 2, thus it's 2/3. So it's 1/3 of 2/3. I'm going to show what happens when you multiply that second winner here by 2. So we have a loser, which is 1/3. This only gives us one permutation, which is AAC. That's the only permutation. But then we take this 1/3 times 1/3 right here, which still only gives us one permutation. But then we multiply that by 2 because we have 2 winners. So that means we have this C right here, and we have the C down here as well, because we have 1/3, which is A, times 2. So we have C plus C. Thus, we went from 1 permutation to 2 permutations. Thus, we have 1/3 times 2/3. But then it's not just 2/3, it is 2/3 of 1/3. And that 1/3 is A right there. But then again, notice we have 2 winners, so we have A and B, thus it's 1/3 times 2. And notice again what that times 2 does. It doubles the number of permutations. So instead of having only 2 permutations, which is this C and that C, it would go AAC and ABC. We've now doubled our number of permutations, so now we can include B right here since we multiplied by 2. So now we have, what do we have here? BAC and BBC. So we've just doubled it again. This is what I meant, how it's tricky and difficult, and for me at least, it took a lot of practice to figure out when to multiply by these 2's because I kept wanting to do it wrong. And I kept wanting to multiply the 2 like right here with the loser or something at the very end. At any rate, you multiply them together, you got your 2/3 times 2/3 times 1/3, which is 4/27. Next practice permutation will be lose, lose, win. So we go from left to right and then right to left. Lose and lose has to be C because C is the only loser. So it goes C and C. And then winner, so it can go A and B. So notice for the winner here, right here, A and B, that is 2/3 of 1/3. So the winner is 2/3 of 1/3, which is the loser. But then that 2/3 of 1/3 is also of 1/3 because that's the C loser right there. Thus 1/3 times 1/3 times 2/3 equals 2/27. Last up, we have a lose, win, win. So we go left to right and then back right to left. So lose will be C and then win, win. So it can go C and just pick one winner even though we have two. So it goes C, A, A. So here we have A and B as the winner. That is 2/3 of 1/3. So it's 2/3 of 1/3. 2/3 is your winner. 1/3 is also the winner, but we have to multiply that by 2 because we have two winners. So 2/3 of 1/3 times 2, which equals 2/3. But this is actually 2/3 of 1/3. So there's your 1/3 for the loser right there. Thus we have 1/3 times 2/3 times 2/3, which equals 4/27 as the number of permutations.